Hey everyone, and welcome back. In this video we're gonna finish it off most of the directives that I have left, the ones that I was unsure about. Of course I asked on Stack Overflow and Rahud Hatterman, apologize if I'm mispronouncing her name, was kind enough to give you a extensive description of the directives that I was unsure of, and of course I'm gonna go over the subroutine directive as well. Wasn't sure why I was tired last time, so it's not related to the macro directive. So I'm gonna go over those and stick around for this video. Alright, so let's start with the subroutine Pseudo Op. And like it says, it isn't really a subroutine but a boundary between temporary labels which begin with a dot. Like I said before, labels is the first. Let me paste this code that I fixed over here. Label has to be the first thing you type on your line, otherwise it's not gonna recognize it as a label. So here's you giving a name and then a subroutine. You type subroutine, and it's right here. Usually temporary labels are using macros within actual subroutines, so you don't have to think of 1,000 names. And that's pretty much the main idea of subroutine, because if you see over here in this example, if I were just assemble this code, it runs perfectly. But as you see over here, we have two of them, have Charlie and have Ben, and each of them has their own set of temporary labels. Here have a .1 and .qq, and it is a subroutine. It's just all of this is on the scope of Charlie, and all of this is in the scope of Ben. All of this is on segmented area of codes. So for example, even though I assemble in run, I can't access this .1 because it's within Charlie. If I were to try to assemble this, I got an error. Fatal error. Doesn't know what's. Let me try to go to QQ. Doesn't know what this .1 is. And exact same thing. It doesn't know what this .qq is because it's within this segment of the scope of this bin area over here. So let me bring it back. And I could put both the same name. For example, like here, QQ. So like the thing says, so you don't have to think of 1,000 different names. And if I could run, you see there's no problem of differentiating between these two, because this is within Charlie and this is within Ben. So it would be a good example, for example, for making a game. And this is like the ship, and this is the missile, something like that. And we both want to loop in both of them, so now I don't have to. So now I can just branch to loop, and both of them have the name loop on it. So it works perfectly. Instead of, well, the alternative would be alternative. This would be like ship loop, you know, something like missile loop, and then they'll have to like branch from this and from this. So you see already that if the subroutine at least a bit more clearer, and we don't have to go through this problem over here. So if I go back all the way, and that's the subroutine directive. So now let's go to the next one, which is the, let's go over here for our friend Rud Hatterman. Was kind enough to answer my question about the ones they left out. And at XXX, which is the force. If you come on your document over here, here it is. XXX is going to replace our instruction, and dot, and then the force is going to replace what type of force you are. And if you go over here, see below, let's go to force, and here it is, extensions. Here you have an example, LDA.Z, and then Charlie, whatever Charlie has. So let me show you guys a quick example. Let me load A. Let me start what's in A, memory 80. Let's load A of 0. And let's load A. Oops. Load A. What's inside the 0. So if we're to assemble this, oh, here it is. Set over here. Here's 42. So, it went back to 0, load 0, and so forth. Well, what really matters is this over here. Load A and A5, which is the opcode, and then 80, which is the hex value. So let me change that to the absolute path. Assemble and go back to the debug. Here, and let me put on the start as well. Here we have both of them is using the as you see over here, the 0 page address. Let's say, for example, for whatever reason I want to use the absolute path. I could force it to do that by typing a dot and an A. So XXX, then dot A, dot. XXX is the instructions, then dot and the force. A is absolute. Let me do this for both of them. So I'm forcing them to use that. And as you see over here, there's 0080 0080. It's reverse order. So as you see, I'm forcing it to use this absolute path instead of the 0 page one. So let me go back without the forcing it. As you see over here, there's no zeros over here. I'm gonna go back to show you one more time. This has 3 cycles. Is it 3? 3 cycles. Force it. 4 cycles. So to show you that it actually worked. So that's the XXX. And you have all the extensions over here. Imply, indirect word, word address, you have byte, 0 page, indirect, word extended, absolute. All of them are over here. And like it's highlighted over here, not all extensions apply to all processors. So that's the XXX forced directive. And now let's go to the next one, which is the list. So the list is going to affect the being written to the list file. And if you come over here in our preference, go back to your assembler, 2600, as you see our parameters over here, you have L, so I wasn't sure of, because if you go list, it says globally turns on and off list, start with the current line. Not really specifying which list, but Root was kind enough to reply to my message, which is replying to this list file. And if you come over here, you can see let me open with a text editor, and here's our list file. So here our table. Oh, no, it's not our list. This is the bottom of the list. So open with text editor. Here it is. You have the passes, which passes it goes to from each levels. This one pass. This is all of our headers. We have it over here, include. So going through all these headers over here. Like I said, it was copied and pasted to the code. Then over here you have a segment. Then it's defining all of that for us. Oh, it's still the macros. And here's our code. As you see over here, seg 80 start frame, all of this. So what we can do, let's say I don't want to show this sync and this sync part because we don't need it. List off and then list on. Actually, let me skip all of that and just put over here, for example, list on. So let's assemble. Let me close this. Let's open again. Text editor. Let's scroll all the way down. List on. And where's this? You don't even have list off. So here, vsync. So vsync over here was the first code, and list on you have LDA and then the percentage sign over here. So all of this was skipped in our list file. So that's what the list on and off does. So let me go back and take off those directives. And let's go over the last one, which is the define value, DV. And over here, expression demonstrates by example. So here I have our, let me copy and paste over here. And then go back to the explanation that he gave. Make it prettier. So as you see, you have our macro eqm, which is a equate eq equate macro, set equate macro. You have a 10 plus, and this is the parameter, kind of like a parameter. If you come over here on our document .doc symbols, holds the value dv pseudo op. So over here, this is gonna use macro. This one is gonna kind of like swap this dot with this one. So 10 plus 1 is gonna be 11, and 10 plus 2 11, so forth. So if I were to compile this and go back over here, you have a 10, which is in hex represent A, and so this symbol 10 is going to be on our output, on our console symbol list. So it's going to go through the, let me go all the way down. It's going to go to my macro. Well, let's go all the way down. No, let's just clear it and run it again. Okay, so we're gonna find my my macro should be an S over here that represents a here it is. S represents the UQM, the equate macro. 10 plus, this is the kind of like a parameter. So if we go to our debug over here, so 10 represents A in hex, so plus 1 it's B, plus 2 is C, and plus 3 is D. So that once the defined value is, we're using this UQM that we have over here. We need to give a name plus a value. So 10, like you showed in the previous video, plus the parameters that we need, and this is the values they're gonna pass through the parameters. So think this as the operand as well. So let me close this, and he go here in explanation. The 1 is replaced by the 10 plus 1 plus 2. The dot acts as a parameter, and so forth. So it's equivalent to DC 10 plus 1 because our assembler is smart enough to do calculations by itself. So if I were to paste this, if we're to like times over here, just to show you that your assembler is smart enough to recognize all this arithmetic. So we have over here B and then 14 and then D, which is exact same thing as before. So this is equivalent to this DC, declared data, which he says again is equivalent to 1, 2, and 3. So that's the good thing of DV. And of course here he has a good example where I have a label, then we define A, B, C, D, and then you another equate macro label plus the insert parameter, and then you have define value macro 1. So it's pretty it's looking at the location of ABC plus 1 plus 2 plus 3 and so forth. So it's going iterating through the values that you have over here. Then he also gives another example here, it's equivalent to this. So this is pretty much it for this video. As we saw, it's a bit too long. In the next video I'm gonna go to the the macro exit and the set, and show you guys what that does. So macro is another way to modularize our code in assembly code. And that's it for this video, and I'll see you guys in the next one. Thank you.